Dear students, under the topic Solving Ordinary Differential Equations with Constant Coefficients Using Laplace Transform, here we have problem 4. Already in our previous video lectures, we have completed problem 1 to 3. So kindly go through it first and then look into this problem. So solve d square y by dx square minus 3 dy by dx plus 2y is equal to 4. Given that y of 0 is 2 and y dash of 0 is 3. These are the initial conditions. Now in order to solve this given question, we have to first of all write this differential equation in the format y double dash, because we know that d square y by dx square can be written as y double dash minus 3 multiplied with what is dy by dx, it is y dash, plus 2y is equal to 4. Now we have to take Laplace transform on both the sides. So we will get L of y double dash minus 3 is a constant which can be written out by using the scalar property under Laplace transform, and then L of y dash, and then we have plus 2 multiplied 2 is a constant, so 2 multiplied with L of y is equal to L of 4. So 4 is a constant which we can take out, and so we will have L of 1. Now we have to apply the formula of Laplace transform of L of y double dash, L of y dash and L of 1 in this equation. We know that L of y double dash is s squared L of y minus s multiplied with y of 0 minus y dash of 0, and L of y dash is s into L of y minus y of 0, and the formula for L of 1 is equal to 1 by s. Now let us apply all this in this equation that we have obtained. So L of y double dash, we have to substitute this, so we get s squared L of y minus s multiplied with y of 0 minus y dash of 0, and then minus 3 multiplied with L of y dash. Here we have L of y dash. Now we have to multiply 3 with each of these terms. So minus 3s L of y, and then here we have a minus. So minus into minus, it will become plus. Plus 3 multiplied with y of 0, and then plus 2 multiplied with L of y, it will come as it is equal to 4 multiplied with what is L of 1? L of 1 is equal to 1 by s. So substituting that, we get 4 by s on the right. Now we shall substitute the initial conditions, that is we will substitute the value of y of 0 and y dash of 0 in these three places. Okay, and then from L of y, that is the terms with L of y, we will take common as L of y. So when we do like that, here we have s square, so L of y minus 3s, so minus 3s, and then here we have plus 2, and what is common in all these three terms? L of y, and then this term we will write now minus what is this, s into y of 0. What is y of 0? From the given question it is 2, so it will be s multiplied with 2, so it will be 2s, and then we have the term minus y dash of 0. So minus what is y dash of 0? It is given as 3. So when we substitute that, minus 3 we get, and then here we have 3 multiplied with y of 0. Y of 0 is 2. So 3 multiplied with y of 0, which is 3 multiplied with 2, and so we will have 6. So as of now I am writing 3 multiplied with, not with this is this minus 3. Okay, this one minus y dash of 0 is minus 3. Now we are doing this, so it will be plus 3 multiplied with 2, which is 6, and then plus is equal to 4 by s. So the next step will be this, we will write as it is first. So s squared minus 3s plus 2 multiplied with L of y minus 2s. What about minus 3 plus 6? It will be plus 3 is equal to 4 by s. Now s squared minus 3s plus 2, okay, multiplied with L of y is equal to, taking these two terms to the right, so it will be 4 by s plus 2s minus 3. Taking LCM on the right, we will have the LCM as s, so it will be 4 plus 2 cross multiply, so s squared minus 3s, and on the left what we have, s squared minus 3s plus 2 multiplied with L of y. Now from this, what will be L of y equal to? Taking this term to the right, it will go to the denominator. So L of y will be equal to 4 plus 2s squared minus 3s divided by s multiplied with s squared minus 3s plus 2. Now we shall use the Hill method and factorize the denominator, that is this term. So we have to factorize the denominator. So I'm just taking and writing it, s squared minus 3s plus 2. So what is the term? 2 multiplied with 1. So we have to find the factors for 2. So 2 1 times, and if we want to add it, we should get the coefficient of s, and it has a negative sign, and so we have to use negative sign for both the terms. And so therefore the denominator can be factorized as, the numerator will come as it is, okay, divided by s multiplied with, here you have s minus 2 multiplied with s minus 1. So this is your L of y. So from this, what is your y? Y is equal to L inverse of 2s squared minus 3s plus 4 divided by s multiplied with s minus 2, s minus 1. Let us mark this as equation 1. Now we shall use partial fraction and find the whatever is there inside the bracket. And after simplifying it, we shall substitute in equation 1. So let us do that now. So I have taken and I have written it separately. So whatever is there inside the bracket. And now if we want to use the partial fraction, we have to separate the denominators. So a divided by the first term is s, plus b divided by the next term is s minus 1, plus c divided by the third term is s minus 2. So we have separated by using these fractions. Now we shall find the value of a, b and c and substitute, for which we have to take the LCM on the right. So when we take the LCM, we get a multiplied with s minus 1 multiplied with s minus 2 plus b multiplied with s and s minus 2 plus c multiplied with s and s minus 1. And the denominator will be the same one which is on the left. So those two denominators on the left and the right will get cancelled, and the numerator on the right will remain. So 2s squared minus 3s plus 4. So this is what we get. Now using this, we have to find the values of a, b and c. So first we shall put s is equal to 0, because very simply if we put 0 here, it will become 0, here also it will become 0. Easily we can find the value of a. So if you put s as 0, so 2 multiplied with 0 is 0, 3 multiplied with 0 is 0. So we have only 4 in the left hand side, is equal to a multiplied with 0 minus 1, so minus 1, 0 minus 2, so minus 2. So from this, 4 is equal to, minus into minus will become plus, it will be 2a. So what will be the value of a? It will be 4 by 2, which is equal to 2. So the value of a is 2. So we have obtained the value of a. Next we shall put the other value. For example, if we put s is equal to 1, this term and this term will vanish, so that we can find the value of b. So put s is equal to 1. So on the left we will have s squared here. So 1 squared. So 2 multiplied with 1 is 2, minus 3 multiplied with 1 is 3, plus 4 is equal to, so here it will become 0. This term, when we put s is equal to 1, it will be b into 1, and then 1 minus 2, which will be minus 1. And this will also become 0, because 1 minus 1 is 0. So from this we get, we have 6 minus 3, which is 3, and that is equal to negative b, because b into minus 1. So from this, the value of b is equal to minus 3. So we have obtained the value of b. Now in order to find the value of c, we have to put s is equal to 2, so that when we put s is equal to 2, 2 minus 2 over here and here will become 0, and easily we can find the value of c. So we have to put s is equal to 2. So if we put s as 2, here 2 squared, which is 4, 4 multiplied with 2 will be 8, and then minus 3 2 times is 6, plus 4 is equal to And then if we put s is equal to 2, these two terms become 0, and c multiplied with s, which is 2, and 2 minus 1, which is 1. So from this we get 6 is equal to 2c, and so from this the value of c will be equal to 6 by 2, which is 3. So hence we have obtained the value of a as 2, the value of b as negative 3, and the value of c as 3. Now we should take this and substitute over here. So a by s, b by s minus 1 plus c by s minus 2. But what is this actually? The term which is there inside the bracket. So directly we will substitute the values of a, b, c over here, and in equation 1 directly we can replace this term with this. So the value of y will be equal to, so we will write here the value of y will be equal to, now here the first term is what? A by s. A by s is, a is 2. So it is 2 by s. So Laplace inverse of 2 by s. So we shall write that. So Laplace inverse of the first term is 2 by s. And then what is the second term? It is b by s minus 1. The value of b is minus 3. So it is minus 3 by s minus 1. And we have to take the Laplace inverse of this term because this term replaces this. So Laplace inverse of b by s minus 1. b is minus 3. So Laplace inverse of minus 3 by s minus 1. So plus Laplace inverse of minus 3 divided by s minus 1. Okay, plus now next term is c by s minus 2. What is the value of c? c is 3. So Laplace inverse of 3 by s minus 2. Now we shall simplify this further. So this will be equal to, so y is equal to 2, we can take common out. So 2 multiplied with Laplace inverse of 1 by s, okay, plus minus 3 can be taken out. So this will become minus. So minus 3 Laplace inverse of 1 by s minus 1. And then plus 3 can be taken out, Laplace inverse of 1 by s minus 2. So this is what we get. Now we shall apply the formula. So y will be equal to, so 2 multiplied with Laplace inverse of 1 by s is what? By the formula we know that Laplace inverse of 1 by s is 1. So that we will write. So 2 multiplied with 1, so it will be 2 only. Minus 3, what is Laplace inverse of 1 by s minus 1? We know that the Laplace inverse of 1 by s minus a is e power at. Now if we want Laplace inverse of 1 by s minus 1, the value of a is 1. So e power t is the answer over here. So for this it is e power t. And then finally we have plus 3 Laplace inverse of 1 by s minus 2. It is the same formula where the value of a is 2. So if we put a is equal to 2 over here, we have Laplace inverse of 1 by s minus 2, which will be e power 2t. So this one. So e power 2t. So e power 2t. So therefore this is the solution for the given ordinary differential equation which we have solved using Laplace transform. So hope you have understood this problem. Thank you.